Good morning, everyone. So this is our next topic, the domain and range of a rational function. Our our objectives will be, so this is our objectives: correctly find the vertical and horizontal asymptotes of a rational function. Correctly find the domain and range of a rational function. So let's move on to our main topic, the domain of a function. It is a set of all values of x. Domain means x, then range means y, that have corresponding values of y. It contains all values that go into function. For example, the domain of f of x equals 5 over x is d equals, or d is to the set of x such that x is not equal to 0. This means that the possible values of x of this function are all real numbers such that x should not be equal to 0. Why? Because since this function is a rational, remember, if it is rational, the denominator should not be equals to 0. And since our denominator is just a variable x, so our rule, the denominator should equate to 0 and find the value of x. So since this is already x, so if we equate this to 0, that is x equals 0. So that means that our denominator, if we substitute x to 0, becomes undefined. So that is why the 0 should not be equal to x, or x should not be equal to 0, because it makes the rational undefined. Okay. Range of a function. It is the set of all values of y that can be obtained from the possible values of x. It contains all possible values of the function. So again, domain is x, then range is the values of y. So example of range. If we have f of x equals 5 over x, this is r. R stands for range. So R is to the set of y. Since range is y, so that is why we will use y. Set of y such that y should not be equal to 0. This means that the possible values of f of x of this function are all real numbers such that y should not be equal to 0. Why is this, that y should not be equal to 0? Do you remember the vertical asymptote and horizontal asymptote? So the vertical asymptote, that is the value of x in the denominator that will be equal to 0 if we substitute it. So it makes the rational function undefined, or it makes the fraction undefined. Then the horizontal asymptote, that's the y values. It means we have the three types of horizontal asymptote, which is n is less than m, n is equals to m, and n is greater than m. If you can still remember, the n there stands for the degree of the numerator, and the m is the degree of the denominator. Here, in our numerator's degree, that is 0, since this is just a number or a constant. If it is a constant, then our degree is automatically no degree, or 0. Then our denominator, we have the degree of 1, since x has the invisible exponent, which is 1. So we have 0 in the numerator and 1. Then 0 is greater than 1, or is it 0 equal to 1, or is it 0 less than 1? Of course, 0 is less than 1. So in other words, if n less than m, that means that y equals 0. So that is why here our range, it should not be equal to 0, our answer. Do not put your answer in your range as y equals 0, same as the vertical asymptote that you put is not equal to. Same as the range, you also put is not equal to. Got it? This means that the possible values of f of x of this function are all real numbers such that y should not be equal to 0. So the possible values of y are all real numbers except 0. That means that y should not be equals to 0. So we have an example. Okay, for example, determine the domain and range of f of x equals x plus 4 over x minus 7. So domain is x, range is y. So our domain, if we will answer it in set builder form, so we will use d equals the set of x such that x, then so on. So this one, how to find the x man? So you have to find first the x value in the denominator that makes the fraction undefined. So this is now our first step. So solution, reduce the rational function to its simplest form. So the given is f of x equals x plus 4 over x minus 7. This is already in simplest form. No, since x plus 4 cannot be factored. Also the x minus 7. Since their numerical coefficient here is 1 and also here is 1. And it cannot be factored na. So it is now in simplest form. So no need to factor it. Then solve for the domain. So to solve for the domain, we have to find the vertical asymptote. So in finding the vertical asymptote, we will equate to 0 the denominator. So our denominator is x minus 7. If we equate it to 0, so x equals 7. Remember that negative 7, if we move here, that will become positive 7. So that is why x equals 7. And then in answering for our domain, we will make this is not equal to 7. So this is now the answer. Solve for the domain, exclude the vertical asymptotes obtained in the previous step from the set of real numbers. The remaining elements of the set of real numbers compromise. When we say exclude the vertical asymptote, that is why we put x should not be equal to 7. Exclude man, so should not be equal. So this is now our answer for the domain. Domain equals the set of x such that x is not equal to 7. As you can see, this is not equal symbol. This is, the symbol is not equal to. So exclude man, we will exclude the vertical asymptote in finding the domain. This is only for the fraction, in the form of fraction or rational function. So next, solve for the range. So range, that is y, and another term for y, that is for horizontal asymptote. So in finding the horizontal asymptote, we have three parts: n less than m, n equals to m, n greater than m. So if n less than m, that is y equals to 0. If n equals to m, that is the numerator's leading coefficient over the denominator's leading coefficient. And if n greater than m, there is no horizontal asymptote, or we called it oblique asymptote. So note that the numerator and the denominator f of x have the same degree. So as you can see, look at my arrow here. We have x, our leading term x, then the denominator's leading term is also x. So if x, this is automatically, it have the degree of 1, invisible degree of 1, and also in the denominator we have invisible degree of 1. So the degree of 1 over degree of 1, so that their degrees are equal. So if they are equal, that is from the second parts of the horizontal asymptote. If n is equals to m, so in other words, we will get the leading coefficient over the leading coefficient of denominator. Again, get the leading coefficient of the numerator over the leading coefficient of the denominator. So leading coefficient, it comes from the leading term. Leading coefficient meaning it is the numerical coefficient of the leading term. So the numerical coefficient here, we know that there is invisible numerical coefficient 1 here. and here also. So this means that y equals 1 over 1. Or in other words, 1 divided by 1 is 1. So therefore, our range is R equals the set of y such that y should not be equals to 1. Okay, let's hear the solution. Recall that n equals m. Then the horizontal asymptote of the function is the line y equals a sub n over b sub n. The a sub n and the b sub n are the leading coefficients of the numerator and denominator respectively, where the expressions, are the leading coefficients of p of x and q of x. P of x means the numerator, q of x means the denominator. Then, our range for the given rational function, this expression is equal to 1. So that is what I'm talking to you, that 1 over 1 or 1 divided by 1 is 1. So exclude the horizontal asymptote. When we say exclude, our symbol is not equal to. So this is our answer. R equals the set of y such that y is not equal to 1. Okay, next example. Find the domain and range of f of x equals x plus 2 times x minus 3 over x plus 2 times x minus 5. As you can see, our given is already in factored form, which is x plus 2 times x minus 3, and our denominator is also in the factored form, which is x plus 2 over x minus 5. So to find the domain, again, we will equate to 0 our denominator. So since we have two binomials, so we will equate to 0 each binomial. So x plus 2 equals 0, and then x minus 5 equals 0, and then find the values of x. So we can also simplify this one into simplest form, but before that, we have to get the vertical asymptote first. These two, x plus 2 and x minus 5. So this is our simplest form here, since this is cancel, x plus 2 over x plus 2 cancel. So the remaining is x minus 3 over x minus 5. So the numerator and the denominator have a common factor. Recall that when the numerator and denominator have common factors, holes at the zeros are produced. Hence, the simplified form, now this is the simplified form since these two are cancelled. Then, find the vertical asymptotes. In finding the vertical asymptotes, we will not be using the x minus 5 only, we will use the x minus 3 over x minus 5 later na sa horizontal asymptote. But in finding the domain, we have to get the 2x here, or find the x. For example, x plus 2 equals 0, x minus 5 equals 0. So first, we have x minus 5 equals 0. So x minus 5 equals 0, that will be x equals 5. Then we also have x plus 2. X plus 2 equals 0, that is x equals negative 2. So our domain, we will put them together. So D equals the set of x such that x should not be equal to negative 2 and 5. So where did I get negative 2? From here, x plus 2 equals 0, move up from positive 2 becomes negative 2. So that is why x equals negative 2. And here, x minus 5 equals 0, so you will move negative 5 here, so that will become 2 positive 5. So that is why our domain is D equals the set of x such that x should not be equal to negative 2 and 5. Now, we will solve for range. So, in solving for range, we will find the horizontal asymptote by comparing the degrees of the numerator and denominator. As you can see here in the given, they are both equal. So, we have x, degree 1, then we also have degree 1, and here also degree 1, degree 1. So, they are all equal. So, if they are equal, then the leading coefficient over the leading coefficient of numerator over the leading coefficient of denominator. So our answer is 1 over 1, or 1 divided 1, that is equal to 1. And we have to exclude the 1. So we exclude the horizontal asymptote. So our answer will be range is equals to the set of y such that y should not be equal to 1. And then we also have another horizontal asymptote, which is if we cancel this one, the one that I told you that the simplest form of this function is x minus 3 over x minus 5. So we will use this simplest form, not included the x plus 2 over x plus 2, only the simplest form. So solve for the range. The common factor cancelled is x plus 2. Hence, we reject the value for f negative 2. So we will use negative 2. Then solve for the range. So from negative 2, so we will substitute negative 2. Where did I get negative 2? From the x plus 2 that we cancelled. So x plus 2, the value of x is negative 2, just is equate to 0. So we will substitute here negative 2, that is negative 2 minus 3, that is negative 5, over negative 2 minus 5, that is negative 7. So negative divide negative, that is positive. So our answer here is 5 over 7. So in other words, we will also include 5 over 7 in our range. So we have two answers for our range, which is not equal to 5 over 7 and not equal to 1. Next, we have determine the domain and range of the function. Okay, just don't mind this one, this is error. I will delete this. This is error. Oops. This one, this is our function f of x equals x squared. I can annotate mo di ay. I forgot that I can annotate. Okay. Okay. So we have example 3, determine the domain and range. So this is our given. Wala lagi mawa. False alarm dito. Okay. So this is our function given. So we have to factor. Don't mind this one, dili man ma-erase. Balik mas dati. We have to factor this trinomial, no? The factored form of x squared plus 10x plus 25 is x plus, since they are both positive, so we will use x plus 5, then x plus 5 times x plus 5, then x squared minus 25. This is difference of two squares, meaning to say that this first term is squared and the 25 also is a perfect square, so you can square out this one. If you can see this one, we called it difference of two squares. If we have difference of two squares, so our factored form of that is x plus 5 times x minus 5. Remember this one, if you can see difference of two squares, meaning to say our first term is a perfect square variable, our second term is also a perfect square, then we will do this 1. Meaning to say, where did I get 5? We can square root of 25. Square root of 25, that is 5. And we will use 5 here for our factored form. So our factored form is x plus 5 times x minus 5. That this comes from x squared minus 25. As you can see, we have common here. X plus 5, x plus 5. So in simplest form, that is x plus 5 over x minus 5. But before we get the simplest form, we have to find the domain. So again, we will equate to 0 this denominator, which is x plus 5 and x minus 5. X plus 5 equals 0, x minus 5 equals 0. Then this one, so our vertical asymptote, we have x minus 5, which is 5, and we also have x plus 5, which is negative 5. So our domain here, this one, see my arrow, we have d equals the set of x such that x should not be equal to negative 5 and 5. So we will exclude the vertical asymptote for our domain. That is why we will use is not equal to, because we will exclude the vertical asymptote. Next, to find the range, we will go back to our given, which is we will go back to our given, which is x squared plus 10x plus 5, x squared minus 25. So as you can see, we have the degree of 2. Degree means highest exponent. So our highest exponent, we have the exponents here in the numerator, we have 2, 1, 0. So our highest exponent is 2. So we will get the degree in the numerator and the degree in the denominator, and then identify if they are equal, if they are less than, if n less than to m, if n greater than m. So here we know that they have the same degree, so they are equal. If they are equal, that means that a sub n over b sub n, meaning a sub n is our leading coefficient over b sub n is our leading coefficient in the denominator. So this is one numerical coefficient here and also here. So that is again 1 over 1, or y equals 1. Then exclude the 1. Exclude the 1. This expression is equal to 1. Okay, we will exclude the 1, so we will put y is not equal to 1. And then aside from that, we have another horizontal asymptote, since we have two factored form, no? The one in simplest form, which is x plus 5 over x minus 5, because the other one, the x plus 5 over x plus 5, we can cancel it man. So using this simplest form, f of x equals x plus 5 over x minus 5, simply substitute the x minus 5. Where did I get x minus 5? From the cancelled one. The x plus 5 is the one that we are cancelling, or we get cancelled. So equate to 0, so the x is negative 5, because positive 5 move here becomes negative 5. So that is why we substitute here x into negative 5. So this becomes negative 5 plus 5 over x minus 5, that is negative 5 minus 5. So negative 5 plus 5, that is 0, over negative 5 minus 5, that is negative 10. Then 0 over negative 10, that is 0. Do not mind the negative 2. This is negative 5 lang. This is error. Thus, the range of f of x is, look at my arrow since it's not really visible. This is r is equals to the set of y such that y is not equal to 0 and 1. Okay, do you have questions? If not, then this is now your activity. This is just a just write this in one whole sheet of paper, then pass it to me in Curie's room, grade 8 Curie's room. Send your one whole sheet of paper with solution into my room. Okay, thank you for listening and goodbye.